So another important topic is engineering geology and the Singapore geological formations. As a civil engineers in Singapore, so we need to understand their engineering behaviors. It is such a long story, but in short. So we are going to take a look at the fundamental of the earth systems and the rocks and the surface, the process, and then Singapore geology, specifically major soil formation, and the main issues on design and constructions. So engineering geology is the study of the earth. The earth is quite a unique place and a home for millions of organisms, including ourselves. No other planet has the same delicate balance of conditions necessary to sustain life. The geology is a specific study of the origin and history and structure of the earth, how it was born, how it has evolved, how it works. How can it help preserve its habitats for life? Recently, we have suffered from severe tectonic activities and some climate change. This is our role to protect our Earth's planet. Geology is also about physical Earth in terms of the composition and process, as well as the historical Earth in terms of fossil records of its habitats. Some geologic process occur over thousands of centuries, but others arise very quickly, in a 2 seconds, 3 seconds. Of course, we can study these things, but from the engineer perspective, civil engineer, geotechnical engineer perspective, we are interested in the properties and then stability of the ground and soils rather than history of geology, right? So now we should take a look at engineering geologies, which is the subfield geology, and then application of the geology to the engineering study for the purpose of the recognizing and accounting for the geological factors regarding construction design. So it deals with the science to engineering to describe rock and soil with engineering work. On top of that, the engineering geology also identify and predict the natural disaster like a landslide and earthquake, even sinkhole. So in summary, this engineering geology is the interaction between humans and the earth, including mapping, characterizing of the material and properties, and predicting landslide, and soil erosion, flooding, even site investigation, also part of engineering geology. So in between the earth science, purely geology, and then geotechnical engineering, we have engineering geologies. So I do believe you've already studied this topic or systems, but let's quickly review. Our Earth consists of 5 spheres that interact with one another. Atmospheres, hydrosphere, lithospheres, biosphere, and cryospheres. But much attention was given to lithosphere in the engineering geology field and geotechnical engineering field. The Earth's topography can be measured in base of sea levels, right? You studied this in our civil engineering skills, right? In this case, mean sea level is being used. So the height of Everest Mount, Rocky Mounts, all are based on mean sea levels. Here is the sign conventions. The elevation in positive represents above the sea level, above the mean sea level, and the elevation in negative means the below the mean sea level. But a bit different story in the geotechnical engineering field. The elevation is typically set based on the ground surface, not the mean sea level. When you take a look at the borehole logs and borehole data, okay, the next time you can see it. The elevation is measured in base of ground surface. That's why in this case, we put the alphabet capital GL, ground level, in front of the elevations. GL minus 3 meter means 3 meter below from the ground surface, not the mean sea levels. And then let's take a closer look at the crust, where our civil engineers are very interested in, which is the layered structures. Perhaps the offshore engineers may be interested in oceanic crusts. Onshore engineer may be interested in continental crusts. And then I would recommend that you read these slides because I skip a lot of things. Just simply reminds of the engineering geology and earth systems. Now it's time to talk about rock, especially origin and types and cycles. I will simply briefly brief these topics. Rocks are naturally producing aggregates of minerals. In general, so our rocks are classified into 3 groups: igneous, sedimentary, and the metamorphic rock based on the Earth's process. This Earth process form 3 different rocks. These 3 families of rocks are formed in a different geological environments by different geological process. What they mean is that number of geological process can transform one rock type into another, which is the rock cycle. These sediments rock are primary material that comprise the Earth's crust. Sediments are solid fragments of inorganic or organic materials resulting from the weathering of the rock. And then they are transported, deposited by wind, water, or ice. Transportation agent. So this geologic process, like the plate tectonic and climate change and climatic systems, can transform one rock types into others. So we start with the sediments eroded from the continental interiors, and the sediments are deposited in the lift basins where they are buried to form the sedimentary rock. And then this sedimentary rock become metamorphic rock under high temperature and high pressures. And then molten magma become igneous rock, turn into sedimentary rock due to weathering process. Our crust and continent and uplift, and then wind, water, ice make our rock into the smaller particles, and they travel from high to lower levels, is the different energies, high level and low level of energies, and then deposit and go into deeper, and then became metamorphic rock, and again exposed to the our dynamic environment. This is the rock cycles. That's why the surface process is quite a important process to promote rock cycles. In fact, it is kind of interactions among the hydrosphere, atmosphere, and the biospheres, and then energies that comes from solar radiations. So this surface process can be divided into 5 stages: weathering and erosions and transportation and deposition and diagenesis. These continent and rock are exposed to our climatic dynamic conditions, and then weathering process will take place. And then the products of the weathering flow down to lower part of the earth and entering the existing material on the earth surface. These several surface processes contribute to the formation of sedimentary rock. And then erosion, transportation, depositions, and diagenesis. Diagenesis is the process that describes the physical and chemical changes in sediments caused by water rock interaction and compaction after their depositions. These 5-step surface process, our rock constantly cycled, turn into one another's. So our Singapore geological formation also came from this process. So as a geotech engineers, the understanding some idea of the soil types and soil information underlying our area of operation is of importance. Very fundamental knowledges. After these lectures, you are very familiar with our Singapore, especially Singapore geology, and in particular, their engineering behaviors. Basically, Singapore's nature, their deposits are classified under more than 10 geological formations. Looks like that. This is the newly released new digital geological map of Singapore by BCA in 2021, very recently. But the existing data has been formed by means of major geological formations. And this major formation will be discussed in these lectures with their characteristics associated with engineering challenges. Because the new formations just released, so we don't have enough data to discuss, but the classical geological formations is we have tons of data to discuss, saying Jurong Formation to the west side, and then Bukit Timah granite, and then also have the old alluviums. Here's the number 7, the orange, and then Kalang formations. Here, the number 10. These 4 geological formations, Jurong formations, Bukit Timah granite, Kalang formations, old alluviums. This is the representative geological formation in Singapore. Other geological formation tends to exhibit similar engineering behaviors and engineering characteristics to our 4 geological formation, and their proportion also very minimum. But it is worth to think through about the recent work done by BCA. BCA has conducted ground investigation to reclassify or refine the geology of Singapore. They investigated more than 100 boreholes in 5 areas. For examples, Tuas and NTU to Mandai, and Simpang and Seletar here, and then Bukit Batok, I don't know where here, Bukit Batok to Rebota Park, and then central areas. And based on this new data, Singapore residual soil and bedrock can be analyzed in terms of porosity and uniaxial compressive strength, Young's modulus, and point load strength, rock quality designation, and the P-wave velocity. All are the values from our comprehensive site investigations. These properties tell us their mechanical and hydraulic behaviors. So the BCA analyzed the recent findings on the structural geology of Singapore based on rock cores and rock exposures in Singapore, including granite rock core, sedimentary loggings, and faults of the exposed rock. Throughout the investigations, we have comprehensive phases analysis of the all sedimentary bedrock units and a revised lithospirit graphical framework. A subdivision of the Bukit Timah granite into 7 new units and a revised understanding of the evolution of the bedrock geology of Singapore with better constraint of the ages of the depositions and deformations. And also we have a major step changing in the understanding of the geology of Singapore. BCA, NTU, and other geological specialists from UK helped to develop new things. And also NTU successfully developed 3D geological modeling and mapping of Singapore. This is a one-step advanced model in order to identify rock units and rock names, and then describing the units and correlate their units. It will be invaluable information for civil engineers who are interested in underground constructions. It is not limited to the underground constructions, but to the slope stability. And then this framework can be applicable to other countries. So BCA ended up developing new geological map of Singapore. In summary, the Kalang Formation becomes Kalang Group. All alluvium now is the bedrock formations. Jurong formations, their name is changed to Jurong Group. Bukit Timah granite is now Bukit Timah Center. Upper Marine Clay and then Lower Marine Clay changed their name, and alluvial members changed to Jalam Bassa formations, and then also we have Kranji formations. Despite the effort, I'd like to stick to 4 representative geological formations for this module, which are still the majority of Singapore geologies, which is Jurong formations and Bukit Timah granite, old alluvium, and Klang formations. So let's take a look at the geological setting of the major formations. Here's the Jurong formations. Late Triassic to early Jurassic. It's mainly comprised of mudstone, sandstone, siltstone, which is distributed in west, southwest of Singapore. And then the Bukit Timah granite is mainly comprised of granite, granodiorite, adamellite, something like that. It is located in the central part of Singapore, actually all over Singapore. All alluviums, late tertiary, and then the middle Pliocene, which is the mainly comprised of dense to cemented silt and clay. It is kind of fine material, and it is distributed in East Singapore. The Kallang Formation mainly comprised of soft marine clay, soft, pitty organic mud. You can easily see it near river valley and river mouth. So I will introduce each Singapore geological formation and then its mechanical and hydraulic characteristics. Do you happen to know about our geology history? How it has evolved? So basically, our geology is closely related to Malaysia Peninsula. Our rocks are identical to Johor's rock, identical to our Gombang Norris, Gombak Norite, and the Bukit Timah granite, and sedimentary rock of the Jurong Formation, and deposit of sand and gravel of old alluviums. All sort of the historical things over the time has happened, and then finally we can draw the simple Singapore geological cross sections. Here is the west side in Jurong Formation here, Tuas area. And then also you can see central part of the Singapore are mostly comprised by Bukit Timah granite, and old alluvium in the west, and Karlang formations near the south and the east areas. So let's quickly take a look at the Bukit Timah granite. It is the predominantly granite and medium to coarse grain rocks. They shows light gray, but sometimes pinkish. It underlies about the third of Singapore. It is recognized as a bedrock of Singapore because it also underlies all other formations looks like that. The red one is a Bukit Timah granite. The older rocks were eventually removed already by erosion, and the Bukit Timah granite was exposed. This is the older rocks. This is a Bukit Timah granite, and all the plates that uplifted and already eroded and became already residual soil. Now you can see the Bukit Timah granite bedrock. Sometimes it is exposed to uh, yeah, our environments. That's why the Bukit Timah granite underwent severe weathering process, mechanical and chemical weatherings. It may cause high variations of depths and soil characteristics from residual soil and granites. That's why it is the main characteristic of Singapore soils, which is called residual soils. Later on, if we get a chance, I will explain the residual soil characteristics and then how the digital technologies differentiate these residual soils into more simpler versions. So as a result, coastal weathering is one of the main problems. This particularly causes some troubles for underground excavation work like tunneling, because this tunnel boring machine, TBM, is supposed to excavate the weakened bedrocks, quite vulnerable to collapse. And plus, under high pore pressures due to heavy rain and water infiltrations, and the groundwater table rises, and the sandy material can be easily become unstable and flow like a liquid when exposed during constructions. These characteristics sometimes lead to soil loss and ground settlement. In turn, structural damages and ground subsidence like a sinkhole. Drum formations to the west side consists of a variety of sedimentary rock like a sandstone, siltstone, mudstone, limestone. It exists in the western and southeastern part of Singapore. These sediments were deposited in a shallow marine basin formed between Bukit Timah granite, here Bukit Timah granite, and the main range granite. And then, as you can see, due to the lateral basin compression, something like that, squeeze, there were uplifted, folded, folded, and metamorphosed with high pressure, high temperatures. So this drum formation underlies large part of the Western Singapore, and the strength of the drum formation rock depends on the rock types and weathering stage. Similar to the Bukit Timah granite, drum formation also shows rapid variation in the soil and rock profile, and causing the difficulties in tunneling and piling. Yeah, Singapore geology quite bad in terms of the mechanical hydraulic behaviors. So very hard to design something inside. So it is required to do comprehensive soil investigation to capture highly rapid variations, but it is also dependent on budget, right? So the cracking and prediction of the soil properties is also important part in the Singapore design of the underground structures. For the old alluviums, the top part is soil. And the bottom part has a lot of the attribute of the weathered rock. So clay, coarse, angular sand, and the fine-grained soil like silts and clay exist in the old alluvium areas, very highly mixed with coarse and fine-grained soils. This old alluvium underlies eastern Singapore, and the lateral and vertical variations are rapid and frequent, as expected. So the variability and sandy material and high permeability are the main problems. For example, let's say we face these soils being considered as a bearing layers. We need to improve these soils by compacting the soils, something like that. We can't design as it is. We need to come up with an idea to improve our ground, lowland ground. The last geological formation, Kalanguru Formation, consists of sediments with marine, alluvial, littoral, and estuarine origins. The Kalang Formation is a typical Singapore marine clay. These Kalang Formation cover much of the coastal plain and immediate offshore zone, which is the nearly 20% of total land surface of Singapore. So I'd like to highlight that upper marine clay can be regarded as very soft to soft clay. It's like similar to that of the Play-Doh, slightly steeper than toothpaste. It sounds like very weak layer, right? But fortunately, lower marine clay can be described as the soft to medium stiff clay. But these soils, clay soil, exhibit large consolidations, large settlement due to additional load and water drawdown. Marina Bay Golf Course. In this specific construction site, we are now building some specific the park and then sports complex. But now we are doing soil consolidation process to get higher strengths. We can't use as it is. So special attention was given to that soil because the soft marine clay showed low strength. It means that there was no bearing capacity. When you stepped on it, your foot stuck in the clay. So nobody tried such shallow foundations resting on this marine clay directly. So the deep excavation work require a very substantial supporting systems. So Singapore engineers used to adapt a permanent substantial retaining wall. It's called diaphragm walls. All MRT stations adapted the wall to support the low strength soil bodies. And the soft marine clay is highly compressible, so it may cause large settlements. The pretty big problem is that the soft marine clay is highly impermeable. The void ratio is very, very small, so the settlement occurs forever. That's why we need to do something more. So if this problem cannot be solved before the construction or during the constructions, the settlement will take place during the service life of the structures. So it may cause structural distress and damages, possibly even collapse. So our civil engineers have to come up with how can we accelerate the settlement and the consolidation process. This is our role. Engineers always give solution. Scientists give us some solutions of the fundamental phenomena. Engineers prepare solution for issues and problems. So in this case, we used to use the vertical drain method to expedite the water drain from the soil. I've prepared some comparison table for the Bukit Timah Granite and Jurong Formation in terms of some strengths and the permeabilities, some in-situ stress, something like that. You just read off all the tables for your better understanding.